Hello everyone, my name is Rogério Ferreira Jr. I am from Brazil representing IMED College. And I would like to present the work named as Evaluation of Aluminum Powder in the Production on a Lightweight Geopolymer. This work was realized in partnership with the Civil Engineer Graduation Course and the Civil Engineers Master's Program, both from IMED College. Geopolymer is an alternative cement that emits low percentages of carbon dioxide to the atmosphere during the phase of production, and it's cured on environmental temperature. The geopolymer are cements produced by the activation of a material rich in aluminum silicate through a highly alkali agent, commonly composed by a hydroxide or an alkali silicate. What originates the geopolymer is a dissolution reaction, where the aluminum and silicon oxide detached from aluminum silicate surface and recombining, forming silica and aluminum tetrahedrons, connected by oxygen. The use of aluminum on the confection of lightweight blocks are well diffused. The autoclaved cellular concrete block is an example of this usage. The use of this material in geopolymer begins like a purpose of upgrade the thermal properties and reduce the structure's weight, since through the metal corrosion process, gaseous hydrogen is produced, which generates internal pores. The objective about this research is to obtain a lightweight geopolymer with aluminum powder through the addition of different levels of aluminum powder on the mixture and identify how this addition affects the compressive strength and density. For the experiment, it was used as precursor the metakaolin. The activating agent used was produced with a 12 molar sodium hydroxide solution and sodium silicate mixture. The void introducing agent used was aluminum powder. The dosage was based on silica to sodium module. This value was 0.50, calculated from the molar mass. The precursor material was dosed from liquid to solid ratio, established in 0.31. The aluminum powder was based on specimen total mass, corresponding to 0.0%, 0.10%, 0.20%, and 0.25%. The compressive strength tests were realized on age of 1, 7 and 14 days. The experiment development was based on two variables. First of them was aluminum percentage, with 4 different levels. The second was the cure time, that varied in 3 periods. In the compressive strength graphic, it is possible to identify a drop of approximately 75% of its resistance occurred with the addition of aluminum powder. This is attributed to the production of pores inside the matrix. Thus, when applying a load, the energy ends up being distributed in a less effective way, since the contact area of the solid material is reduced compared to less porous matrices. In the samples where there was no addition of aluminum powder, there was a strength gain over the days. However, it is observed that in samples with addition of aluminum powder, the strength decreased after 14 days of curing. In this topic, it is possible to identify that the greater amount of aluminum powder, the lowest density, having a considerable reduction compared to the material without aluminum powder, in the range of 40%. Each grain of aluminum powder becomes the nucleus of a pore. This explains the reason for the density reduction with the addition of aluminum powder. However, other factors such as the dispersion of the aluminum particles and their granulometry can influence quantity, dimensions, and mainly in pore intercommunication. When evaluating the lightweight geopolymer with aluminum powder, in general, it is possible to identify that the density and compressive strength of the geopolymer does not follow a fixed logic. In this case, where the density decreased due to water evaporation, it does not refute this conclusion since, for the same curing time, The sample with the lowest density did not present the slightest strength. Another point that makes this material interesting is the curing time. It was observed that the heating caused by the addition of aluminum powder accelerated the hardening of the geopolymer, allowing it to be unformed in just 30 minutes. It's a great advantage when thinking about fast production. Studies report that geopolymeric materials have a final cost 10 to 30% lower than ordinary Portland cement. Regarding the use of the developed material, its application in internal walls becomes interesting. It can replace the materials currently used as the autoclaved cellular concrete block. As discussed in the literature, this material has thermal and acoustic insulating characteristics, as well as high resistance to fire and acid attacks, parameters which are widely discussed in the area of housing comfort and quality of life. The tests performed with the addition of aluminum powder showed good conditions of strength and density. It is an alternative material with less environmental impact and has a low density, being an excellent option when a reduction in structural load is required. The authors thank Image College for making available the laboratories, equipment, and materials used in the experiment. They also thank the Coordination for the Improvement of Higher Education Personnel and the National Council for Scientific and Technological Development for their support in the form of scholarships of study.